today so far. Is it?
So why factoring, right? Why factoring, okay? The reason we factor is so we can now have an equal sign and a zero so we can solve, okay? So in order to do that, we first need to review what the zero product property is. The zero product property says if I have two things multiplying and it equals 0, what do I know about A and B?
There's 0.
One of them has to be 0, right? So in order for this to equal 0, either A has to be 0 or B has to be 0 or both. If I'm multiplying and it equals 0, one has to be 0, okay? So that's when we use factoring. And let me just show you an easy example here quick. If I were to factor and say, okay, what do I multiply equals 2 but add equals 3? 2 and 1, so it factors. Now, instead of just factoring, we're going to have this set equal to 0. Okay? So if I am multiplying right here, either this has to equal 0 or this x plus 1 has to equal 0 because I'm multiplying them together. Okay? So I can think mental math, what plus 2 would make this equal 0? Negative 2. If I put in a negative 2, negative 2 plus 2 is 0, and 0 times x plus 1 is going to be 0. Or what plus 1 would give me 0? Negative 1, because negative 1 plus 1 is 0, and 0 times x plus 2 is still going to be 0. And what is this solving for? What you're doing is if you have a parabola, we learned with parabolas that minimas and maximas, right, are a big deal. Like this min, I could minimize something, I can maximize something. The other important property of quadratics are these right here, these x-intercepts, which we also call roots and zeros. Right? There's 3 words that mean the same thing. X-intercepts, your roots, your zeros. This is what I'm solving. So it crosses at negative 2, 1, negative 1 and negative 2. So when I solve the factoring, I'm solving for where is it crossing the x-axis. So when I get answers today, that's what I'm solving for. I'm solving for the roots, the x-intercepts, the zeros. Okay? So let's do some examples here. Okay, so factor. What do I multiply equals negative 24, but add equals negative 2? Negative 6 and 4, good. Right? Negative 6 times 4 is negative 24, negative 6 plus 4 is negative 2, so it factors. What? Negative 2? Negative 2? Okay, so see how I'm multiplying right here? I'm multiplying. So either x minus 6 has to equal 0, or this x plus 4 has to equal 0 for the whole thing to be 0. Right? So mental math. What minus 6 would give me 0? 6. What plus 4 would give me 0? Right. Those are my answers. And to just show you one more time, you don't have to write this. I just want to show you. What this means is I'm crossing the x-axis at negative 4 and 6. That's what I'm finding. I'm finding the roots. Okay, that's what you're solving for. It means something. And I'll show you, when we do some applications, I'll show you what it means later. Okay, so let's do some more examples. No. There we go. Let's just do the one below it. I like that one. What do I multiply equals 9, but add equals negative 6? Negative 3 and negative 3. Very good. Because negative times negative is positive. Negative plus negative is negative 6. So I can write this as x plus 3 times x plus 3, which is x minus 3 squared. Right? 4 times 4 is 4 squared. 2 times 2 is 2 squared. X minus 3 times x minus 3 is x minus 3 squared. So what that means is I'm only going to have one answer here. because what number squared would give me 0? 0 squared. So what minus 3 would give me 0? 3. Yep, 3 minus 3 is 0, and 0 squared is 0. What this means, right, I always have 2 roots, but this is only 1 root. What that means is that my minimum is touching the x-axis. So it has multiplicity. It has positive 3 is happening twice. That's multiplicity, and that's what it looks like when you have a minimum or maximum that touches the x-axis. And that'll be next chapter, but I just wanted you to know there's always 2 roots, except for when the vertex hits the x-axis, then we have 1. But it has multiplicity. It happens twice, so there's still 2 roots. But we'll worry about that more next chapter. Let's try one with A not being 1, right? If your quadratic's not in standard form, you do need to get it into standard form, and you always want to keep the A term positive. So I would subtract the x over, subtract the 4 over. So I get 3x squared minus x minus 4. Now this is when you're going to have to do that mental math, or you can do that approach I taught you yesterday. So let's look mental math first, because I know some of you are doing that. 3x squared has to be 3x and x. So now I'm looking, okay, what combination of 4, 1 and 4, 4 and 1, 2 and 2, where my outer inner is going to equal negative 1? You guys got it? So try some, right? 1 and 4, that'd be 12 and 1, that doesn't give me 1. How about 4 and 1? 3 and 4, can I get a negative 1 out of 3 and 4? And it'd be a positive negative, because that would give me a positive 3 and a negative 4 to get negative 1. Okay, now let me show you the other way, just for those that need it. Okay. We learned yesterday you take the A to the C term, and then I can factor the usual way. What do I multiply equals negative 12, but add equals negative 1? Negative 4 and 3. So this factors x minus 4, x plus 3, but if the 3 goes away, the 3 has to come back. Can I factor anything out of 3 and 4? No. Can I factor anything out of 3 and 3? Yes, a 3. And whatever you factor out just goes away, and I'm done. So you have the same factors. Okay. Now, to solve, it's going to be a little bit trickier because equals 0, and this is where I'm multiplying. This one's the easy one. What plus 1 would give me 0? Negative 1, okay? Now look at this. 3 times what number minus 4 will give me 0? Okay, if you don't know, you have to set it equal to 0 and say, okay, 3 times what number minus 4 is going to give me 0? And use your Algebra 1 skills. So add 4, divide by 3, and it's 4/3. Okay? And after you do some of these, I'd hope you could do that in your head. If you solve this, you could say, oh, to order of operations, I would add 4, divide by 3, 4/3. Okay? But if you don't know, you're going to have to write it out. Use your Algebra 1. Let's try another one. The one below it, again, I want to keep the A positive, so I would minus 24x, and that would go in the middle. You always want to keep your A term, then your B term, and then your C term. Okay. Now, if you can ever factor something out, you want to do that first because it makes factoring easier. So when I write out this problem, I kind of notice that, oh, wait a minute, 3, 24, and 45, they all have a common factor. What can I factor out of all 3 numbers? A 3. And by factoring out a 3, See how it makes my numbers smaller, and it even made my a 1? So I can factor the easier way. So from here, I can say, okay, what do I multiply equals 15, but add equals negative 8? Negative 5 and negative 3. Okay. So I still have the 3 there, but now I have x minus 5, x minus 3, and it's equaling 0. Right? So now I need to think, okay, what x values are going to make this equation equal 0? So this is where I'm multiplying 3 times x minus 5 times x minus 3. 3 is one of the things getting multiplied, but I really can't make 3 a 0, so we're not going to worry about that. But I can make x minus 5 a 0 by putting what value in for 5? 5. And I can make x minus 3 0 by putting in what value? 3. There's your answers.
3 doesn't mean anything?
It just means vertical stretch of 3, which stretches and compressions won't change your roots. So let's look at some distributing factoring ones when I just have 2 terms, like this one. So I just have 2 terms. You want to keep the a term positive. So I would subtract the 21x over, set it equal to 0. Okay. Now this is that reverse distribution. So I look at both terms and I think, what can I factor out of both terms? Here's a 7 and a 1 and 2 x's. 21 is 7 and 3 and an x. So what can I circle in both? A 7 and an x. Very good. So if I take out a 7 and an x, what's left in the first term? X minus what's left in the second term? Yep, 3. So if this equals 0, and I am multiplying right here, 7x times x minus 3. So I look at this. 7 times what number would give me 0? 7 times what equals 0? 0. Mm-hmm. And then look at this one. What minus 3 would give me 0? 3. There's your answers. Try another one of those. All right, I'll get there. Okay, so look at here. What can I factor out of both terms? 4 is 2 times 2 and 2 x's. 6 is 2 times 3 and an x. So what can I circle in both? 2 and an x. Good. So if I take out a 2x, what's left in the first term? 2x. What's left in the second term? Mm-hmm. And that equals 0. And I'm multiplying right there. So looking at these 2 terms getting multiplied, 2 times what would give me 0? Mm-hmm. What would this one be? 2 times what plus 3 would give me 0? You do that in your head yet? Very good. If I were to set this equal to 0, how would I solve? I would subtract 3, divide by 2. So negative 3 halves. See that? If I set 2x plus 3 equal to 0 and solved, I would subtract 3.
Will it always be just like that?
Divide by 2. Yep. Yep, you should be able to start doing those in your head. Think order of operations. What am I going to do to solve? I'm going to first subtract the 3 and then divide by 2. So negative 3 halves. This example, again, you're going to want to keep the 24 positive, right? You always want to keep that a term positive. So I would subtract x over, subtract 3 over. Okay, instead of equal to 0. So this one's a little bit trickier to factor because my a term has lots of combinations. 1 and 24, 2 and 12, 3 and 8, 6 and 4. So I would start with the c term last and do 1 and 3 instead. And then think, okay, what outer inner is going to give me negative 1? So I can start trying some things like 4 and 6. 12 and 6, can I get 1? No. 6 and 4. How about 24 and 4? Can I get 1? No. How about 3 and 8? Can 9 and 8 make a negative 1? So there it is. So I would say a negative 9, positive 8, right? If I did negative 9, positive 8 is negative 1. And then last, negative 3, first, 24. Okay. I'll do the other way. One more time. Okay. So I would take the A to the C term. 25 times 3 is 75. 75 minus 3 would be 72. So then I'm saying, what do I multiply equals 72, add equals negative 1? Negative 9 and 8. Right? Multiply, add. So it becomes x minus 9, x plus 8. But if I take the a term away, I have to put the a term back in. What is the greatest common factor between 24 and 9? 3. Yep. So if I take out a 3, I get 8x minus 3. What's the greatest common factor between 24 and 8? 8. So I would get 3x plus 1. So same factors, right? Same factors. But now I do need to solve. So can you guys do that in your head yet? If this equaled 0, 3 times what plus 1 would give me 0? If I set that equal to 0, what would I do? Subtract 1, divide by 3. So what's my root? Negative 1/3. If I was going to set this equal to 0, right, and solve, what would I do? Add the 3, divide by 8. So what's my root? 3/8. Okay, so practice that. It'll save you time. Again, if you don't know, you guys said equals 0, right? Use your algebra. And you get the same thing, negative 1/3. That's where it's coming from. But try to do that in your head. Okay. The last example, I just threw that in to kind of show you what's coming tomorrow with this. Because I'm sure you're all wondering, if I'm finding roots of a quadratic by factoring, well, what happens if the quadratic's not factorable? Right? And tomorrow we'll see that, what happens when it's not factorable. But just to kind of show you, if I have vertex form instead of standard form, I can still solve for x. Right? Because to solve for this x, I need to get rid of the parentheses. In order to get rid of the parentheses, I need to get rid of the squared. How do I get rid of a squared? Remember? Square root. Remember that? So a square root cancels that out, and I'd get x plus 2 equals plus or minus 7. Okay? In this chapter, every time we square root, it's plus or minus. Because 7 squared is 49, negative 7 squared is 49, and we didn't know what 7 got squared to equal 49, so we have to consider both. Then, when I subtract 2, I have to solve for both. Positive 7 minus 2 is 5. Negative 7 minus 2 is negative 9. Okay? So vertex form we can still solve just by square rooting. Okay? But your assignment to finish that 1 through 15 is just the bottom of the page. You're just factoring and finding your roots.